Hello everyone, my name is Dimitry and I work for ERP scan company, and today I will tell you how to compromise an SAP system via SAP user password disclosure. I think this talk will be useful for penetration guys who often see the SAP system in corporate network but do not know how to get in. So let's start. A little bit about company where I work. The company I work for is called ERP Scan. We are the developers of ERP Scan Security Monitoring Suite for SAP, and we conduct security assessment of business application, embedded systems, and mobile systems. We find various vulnerabilities in them and get acknowledgement from vendors. So, and the last blah blah slides about me. I'm yet another security researcher. I work in the field of information security, and in particular business application security. What's more, I and my friends are the organizers of hardcore security conference in Russia, 0 nights. So if you want to visit Russia, you're welcome. Let's start. Who knows what is SAP? Few guys, okay. Just start. SAP is the most popular business application. More than 250,000 installations all over the world. But people spend enormous amount of money to install this ERP system, and they forget about security. In ERP system, all business processes are performed, all critical information is stored, like financials, HRs, clients, and not to care about the security of this sensitivity data, it's not very sensible. SAP security. What goals do attackers often have? Espionage, fraud, and sabotage. First of all, it's espionage. Some kinds of stealing information, stealing financial information, stealing corporate secrets, stealing supplier and customer lists, some HR data. Second one, fraud. Like a false transaction or modification of master data. And finally, it is sabotage, some kind of denial of service attack, modification of financial reports, and of course, access to the internal corporate network and access to the other internal system like a SCADA, using trust relationship. And that, it's possible because SAP system is a place where all data from other system comes to be stored and proceed. That's why it's possible to attack other system after compromising SAP system. And that's why it's very important to protect SAP system. And someone told us SAP system available only in internal corporate network. There is a myth that SAP is not accessible and cannot be attacked from the internet. As the system becomes more and more popular, cloud services and mobile solution appears, so more and more SAP services become accessible from the internet. We have scanned the internet for various SAP services, and we found a lot of different SAP systems, a lot of different SAP components and open ports on different countries. And as I said, we scan the internet and try to find open SAP ports. And one of the most popular SAP ports, for example, it is SAP service MMC. It is SAP Management Console. It provides a framework for centralized system management. Using this framework, SAP administrator or attacker can easily monitor and control the SAP system. He can start or stop some instance of SAP, display SAP logs and trace files, start profiles, some instance parameters. Maybe he can display environment, etc. Also, he can display control Java processes, monitor system alerts. So it's very useful tools. But what's important, many of features of this SAP MMC available without any authentication. For example, reading SAP logs files, reading traces files, some kinds of process information. Attacker can easily get this information when he sends SOAP request. He will get the response with all needed information. As I said, mostly it is information disclosure attack or denied of service attack, but information disclosure like a remote file reading, it's very important in our case. Why? I will describe a little bit later. This is example, simple example how an attacker can easily get content from any file from the server of SAP, just using function read log file. He point which file need to read, and he will get this file. Why are and without any notification, of course. Why are vulnerabilities which allow to read any file from SAP is important? Because SAP stores a lot of sensitivity information in files. It can be log files, traces files, some configuration or properties files. Of course, most of them have a protection like encryption. But today I will try to show you how you can easily bypass this encryption. As I said, if an attacker can read a file from the server, they can get clear text password of SAP users, and as a result, compromise the full SAP landscape. SAP has a lot of different vulnerabilities, which allow attacker to read any file from the server or execute command of operating system. Just view our previous presentation, and you will find a lot of information about these vulnerabilities in SAP. But in this talk, I will show where attacker can grab some SAP password if they have access to some files on the SAP file system. It's talk based on our works on reverse engineering of few SAP services which work with users' passwords. And start with default passwords, of course. There is a list of SAP default passwords, 5 users with few default passwords. And when you start trying to pen testing SAP, first of all, check this password. Very often, administrator changes this password on the product system, but forget about developer systems or quality assurance system and different clients. So go next, password on client side. This is, I don't know, can you see this? But there is a list of some vulnerabilities which was founded in ActiveX component, which was installed when administrator installs the SAP GUI on the client system. SAP GUI is the most popular SAP client software. So when the administrator installed SAP GUI, he also installed a lot of ActiveX component. And these ActiveX components also have a lot of different issues which allow the attacker to execute remote command execution or display files through the insecure method. And also it's possible to attack client through some software vulnerabilities like a buffer overflow in SAP Logon, for example. And what after that? Of course, first of all, try to find SAP Logon shortcuts. Often lazy users store password for SAP account in shortcuts. That's how shortcut looks like. It's just a TXT file with some parameters, and one of them password string. And this is another view of shortcuts. And this is a string with encoded password, encrypted password, PV just a static char, and after that go encrypted passwords. In my shortcuts, I save default password 06071992, and as a result, I got this hex string, which looks like just XOR encrypted password. After a few experiments, I found yes, this XOR encryption, I got a key very easily. Checks this key on different version of SAP GUI and understands the key is static and equal for different SAP GUI and on the different version. On the slide you can see the part of the key. On this and the next slide I will not publish the encryption key because we have some agreements with SAP company, but the way if you will send me a message, I will give you all this stuff, and also I give you a tool for decryption, so, but not on the slide. And of course, there's a little Python code for description and list of prevention action. Do not use old version of SAP GUI and patch some SAP notes, and do not store password in the shortcuts. Okay, go next. Password from tables user 02, USH 02, and user PVT history. This is the most well-known area of SAP passwords. In this table, SAP stores all information about user, client number, name, password hash, etc. So if an attacker can read this table, he will get a lot of interesting information about user. But what's important? Information about password hash. For hashing, SAP use few algorithms like coding A, B, D, E, F, G, H, I. First 5 I do not recommend to use. They hash only first 8 charts of password and do not care about case sensitivity. That's why this hash very easy to brute force. Other based on the SHH one algorithm, but the way you can still use a Josh the Ripper tool for bruting them. It's not so interesting. A lot of SAP notes about that. Go next. The next one, the passwords from RFC request. What is this RFC? RFC is remote function call. RFC used for communication between different SAP systems, between SAP systems and non-SAP systems, and of course for executing some users requests. So this means SAP use RFC request very often. This is how a RFC request looks. As you can see, all data transmit without any encryption. You can see username, function name, some data, but you will not see the password because only user password was encrypted by default. And as I said, if attacker will intercept the RFC request with login data, he will be happy because he got the login password. But after that, he will be upset because the password is encrypted, and again happy because the password is just, again, XOR encryption with static key, with different version. So that's how very easily using this P script you can decrypt password from RFC. And again, some action for defense, just use RFC security connection through SNC. The next site application, which will be described, is SAP Visual Administrator. SAP Visual Administrator, it is a remote tool for controlling J2 engine. They use for their works SAP's proprietary protocol P4, and by default, all data transmitted in clear text. That's how P4 protocol looks like. Again, a lot of clear text information about some Java classes, about function names, but again, password is encrypted, and again, it's XOR. Because Visual Admin is a Java application, we can easily decompile them and understand which encryption is used. As you can see, all password charts XORed with static hex value AAA. And once again, this key is hard-coded in all versions of Visual Administrator. So now attacker knows the key, and now he can easily decrypt intercepted user password. And again, few prevention. Okay, go to the server side of Java stack of SAP system. Start with Java Security Storage. What is that? Security storage, this is a place with Java application server used for storing sensitivity information like a database user and its password, database connection information, administrator user and its password. Security storage plays on the file system in file secstore.properties. On the slide you can see the default path to this file. And looks on this file, you can see the word like a host, password, etc. But the value of these things is encrypted. Our research shows for encryption, SAP used triple depth algorithm. Probably we need a key for decryption this stuff. Let's look. And the main problem of Java Security Storage, the key file is located in the same directory as the encrypted data in file secstore.key. If we look deeper on this file, we will see it consists of two parts. First, version information, and second one, encrypted key phrase. Version information is very important because depending on version, the triple depth key may be changed. For example, if version above 7.0, this means key equal key phrase plus SID of SAP. The next one is encrypted key phrase. By default, it is the initial password which the administrator set up during the SAP installation. Often this phrase equal to the DB passwords or SAP administrator account passwords. And for encryption, the key phrase XOR algorithm with static key is used again. That's why if an attacker only got the secstore.key files, they can also get access into SAP because they have the initial password. Okay, now we have the encrypted password from secstore.properties file. We have the decrypted key from the secstore.key file. Now we can try to decrypt data from secstore security storage. And as I said, data is encrypted by triple depth algorithm in CBC mode using a secret key and with salt equal 0. We wrote a tool which decrypts all this stuff from SAP Java application server and successfully use them on our penetration testing. Also, SAP Security Store file can have another name, for example, gupgrade.properties, but the algorithm is the same. And this file also stores other interesting information like a password for some SAP operating system users, database password, internal username and password, etc. And of course, some prevention measures. The next one thinks log and trace files. SAP can write a lot of logs, and the administrator can define which logs and the verbosity of these logs level. And if an attacker can read logs, for example, through the SAP MMC, for example, he can find many interesting things in log files. Information about the system, information about the user, even information about session of user. But administrator, as I said, can configure logging. By the way, in SAP system exist few places where log store does not depend on the desire for the administrator. For example, log file from directory SAP inst dir. This directory stores the files which used during SAP installation processes, and in this folder attacker can find many interesting log files. Let's see. This is a typical log from this directory. As you can see, the password is replaced. Okay, go next. Yeah, it's look better. Attacker can find a clear text username and password in log files, but be honest, this situation does not happen not so often. So go next. This is more real situation, which we see very often in SAP logs. Password in logs file is encrypted. Goose, what type of encryption is used? Right. Again, XOR, and again the key is hard-coded, and again it does not change. As a result, we have a decryptor of password from SAP logs file. And the same story with some auto-generated config files by SAP. And prevention, do not use trace level equal 3, and of course, delete traces when work is finished. And go the next SAP modules, it is SLD, and password from SLD config file. SLD, it is the central information repository for SAP system landscape. It contains information about technical system landscapes, business system products, software components in SAP system landscape. And so, of course, SLD has a config file. Its name is sld.cfg, and it stores information about username and user password, host name, and port value. And all this stuff and encryption is encrypted by DES algorithm in the early version of SLD and triple DES by modern version. By default, for encryption, SAP used default hard-coded key. But this key, part of this key you can see on the slide. But if user want to change default key value, then the key will be random generated and will be saved as sld.cfg.key file and placed near the encrypted data. So that's why the key is not a problem if you want to decrypt information from SLD config file. And as I said, in the latest version of SLD, another algorithm is used. It is triple DES with hardcode key. Few prevention to defend your system. Just read access to the important file. Okay, go to the ABAP stack, the place where ABAP stack stores sensitivity information. It calls ABAP Security Storage. The security storage is a component of SAP. It allows the encrypted storage of sensitivity data that SAP application require when logging into other system, like RFC destination, exchange infrastructure, LDAP system user, etc. And all this data stored encrypted in SAP table RSec tab. How attacker can get access into DB? A lot of ways. If attacker can execute operating system commands on SAP server, that means he has opportunity to connect to the database without any credential. Also exists another ways which do not require remote command execution on the server, but it is out of scope of this talk. Now, how SAP encrypt this data in security storage? First of all, SAP create this structure. And these two versions of the structure depends on the version, but in the modern version of SAP use the version number 3. Besides the data, also encrypted some additional information like a SID of the system, instance number, and some magic values which be used later. That's how the structure looks. Start with random numbers, after that payload, the green is payload. After that some signature, checksums, and SID. For encryption, the triple DES algorithm used the DES ED3 method with 24 bytes keys is supplied. This means there are 3 DES operations in the sequence encrypt, decrypt, encrypt with the 3 different keys. The first key will be bytes from 1 to 8. The second key is byte from 9 to 16, and the third key is bytes. It is from 17 to 24, and 2 rounds encryption is applied. First round, on this step, SAP encrypt only part of our data. information about random prefix, payload, and some payload information, and some magic values and checksums. And key for first round encryption generated dynamically and based on the default key, which stored with MD5 hash of SID of system and installation number. About the default key, I will tell a bit later. So after first round, we got this picture. The bigger part of data already encrypted, but part of this which used for generating first key still in clear text. That's why we have a second round of encryption. As key, SAP use default key value, and as a result, after second round, we will get encrypted data. What about the default key? It is also encrypted via triple DES algorithm, but the key for the encryption is hard-coded. So SAP System Store hard-coded store encrypted key, encrypted value, and before first round, decrypt this key using another hard-coded key. That's how we'll get default key. Just found encrypted key, found key for decrypting this key, and after that we got a default key for decryption, second round of encryption. And after that, after decryption of second round, we got information about which allow us to generate the second one key for decryption first round. That's how we can decrypt all information and it will get clear text data. And of course, some prevention methods just change the default key. It's very useful. Okay, let's go to another interesting table, DBCon table. As you know, SAP has a connection with different databases, and administrator can manage this connection via the transaction DBCO, and we'll get information from database, some kind of static information. All database connection inform all database connection information which used in DBCO transaction is stored encrypted in the table DBCON. Let's see on this table. That's how DBCON looks. Information about connection, username, and of course password. On this slide, you can see the example of encrypted data. So for encryption, used DES algorithm, and after encryption, the result of encoded using base 64 algorithm. The key which used for encryption is again hard-coded into SAP system and equal on different system. With payload also encrypt, SAP also encrypt static salt with value be happy. And again, prevention, restrict access to the table, DBCon, restrict access to the transaction, DBCO, and implement few SAP notes. And the last SAP modules, which I will describe, it is one of the new SAP product in memory database, SAP HANA. I don't have enough time for reviewing this system. Just go to the password issues. A lot of interesting things HANA store in HDB user store. It is a kind of SAP Security Storage. The default location of this storage is /user/SAP/HDB client directory, all information stored in the file ssf/hdb.dat. As in SAP Security Storage, HANA used triple DES algorithm. And what interesting HANA use for encryption the same default hard-coded key. What And what kind of information we can find into security storage except the password? About that a little bit later. And as I said, SAP HANA, it is a memory database. That's why attacker can't steal information from database file from the file system. By the way, SAP HANA drops some data into file system. It's like a backups and save points, and if power off and after a power failure, the database can be restarted like any disk-based databases and return to its last connection, consistent states. Very cool. That's why SAP HANA provide data volume encryption, which allows to administrator encrypt volume using the IS algorithm. And for decryption volume, HANA use the persistence encryption root key. And the main things where this root key is stored. And exactly, this key is encrypted and stored in security storage in the file ssfhdb.dat. That's how attacker will get a root key and bypass volume encryption. Also API key plays this API key used as a sign in some internal API request. And also the persistent encryption features does not encrypt the log files, backups, and trace files. And as we know, into log and trace files also possible to find encryption passwords. And the prevention change the encrypted key after installation and restrict access to the key file and security storage. And few interesting links. And finally, I want to say it, I do not have enough time to describe all possible ways to get SAP user passwords. By the way, if you just try to grab database using the word password or something like that, you will get a lot of interesting places with encrypted passwords. And that's all. If you have a question, please. And if you need a...
We have almost 10 minutes yet.
Okay.
If you want.
It's cool. I was a quick. Sorry, I think it's information will be useful if you send me a request about these keys and about the tools which allow you to decrypt all this stuff. Because in our works, it's very helpful stuff.
Okay, any questions? Nope. So thank you very much. Big applause, please.